Hello everyone, it's a pleasure meeting you all in my mathematics class. Today let me prove that the set addition modulo 6 is a group under addition. Here what I do here is, see, this Z6 consists of elements 0, 1, 2, 3, 4 and 5. Here each element is called a class. We call it as a class because if you add these two elements, for example you take any two elements 3 plus under addition modulo 6, you add this 4, then this is nothing but 3 plus 4 mod 6. This is a 3 plus 4 mod 6. That means this 3 plus 4 is 7. So this is equal to 7 mod 6. That is equal to 1 into 6. That is equal to 1 into 6 plus 1, which is nothing but, so this 1 into 6 plus 1, so this comes under the class 1. That means here we add two elements, but under mod 6 we write it as a multiple of 6 plus a remainder, and the addition of these two classes when added will fall into the class of the remainder. For example, you see that this is class 3 plus class 4. If you add, it is under order of 6. 3 plus 4 mod 6. And we can put it as a class here. We can put it as a class here. See here. And this is 7 mod 6. 7 mod 6. And you see that the 7 is nothing but 1 into 6 plus 1. So this one remainder is nothing but the class in which the addition of these two classes will fall. So this is called the addition modulo 6 operation. Okay. Now under this Z6 plus Z6 under addition modulo 6 is a group. This is what we are going to prove. So for that, what we do is we draw the table like this. See, we draw the table like this. This is under the addition plus 6, and this is 0, 1, 2, 3, 4 and 5. The 0 added with anything 0 plus 0, you see that it is going to be less than 6. So it will remain as the class itself. 0, this is 0, 1, 2, 3, 4 and 5. And if we take 1, this is 1, this is 2, this is 3, this is 4, this is 5, this is 1 plus 5. You just see that class 1 under 6 plus 5 is equal to 1 plus 5. It is 1 plus 5 mod 6. This will fall in this class. It is 1 plus 5 mod 6. 1 plus 5 is 6. So this will fall under, see, 1 plus 5 mod 6 nothing but it falls in the class 0. So this is 1 plus 5 is 0. Then coming to this 2, this is 2, this is 3, this is 4, this is 5. Now 2 plus 4 is 6. 6 is nothing but 1. We say 6 is nothing but, it is 1 into 6 plus 0. So this will fall, addition of these two will fall in the class 0. And like this 2 plus 5, see, It is modulo 6 plus 5 mod 6. So this is equal to 1. Because 2 plus 5 is nothing but 7. 7 is 1 into 6 plus 1. So this will fall in the class 1. So this is 1. Then 3. This is 3. This is 4. This is 5. This is 0. This is 1. This is 2. Then 4. This is 4. This is 5. And this is 0. This is 1. This is 2. This is 3. Then this is 5. 5 plus 1 is 6, 0. And this is 1. This is 2. This is 3. And this is 4. So this is our table for, this is the table. Table for addition, so this is the table for addition modulo 6. Now you see that the whole problem is solved. My aim is to prove that this Z6 under addition modulo 6 is a group. And this consists of the classes 0, 1, 2, 3, 4. I explained to you what is the meaning of class 1, class 2, class 3 and class 5. And how do you add two elements here? These are the elements. How do you add the two elements? You just add the classes and add the numbers and you write it as a multiple of 6 plus a remainder, and addition of these two classes will fall in the remainder class. So this is what I have done here, explained. And using that addition modulo 6 operation, I am able to get a table of this type. This table completely gives us a picture of, to show that the Z6 plus 6 is a group. So how it is done? See, let us take any two elements. First of all, we must prove that closure property. What is our closure property? Closure property. First one is check for 1. See, check for 1 closure property. See, any element, you take class A, class B belonging to Z6. Class A plus class B is equal to class C, and class C belongs to Z6. Correct or not? So you see that you take any two elements and your elements are only this much. You take any two elements and you add, you get another element which is again a class because of the remainder that we will get on adding two numbers. Okay, that tells you the class in which it falls, and this class C will again be an element. For example, you see that this 4 plus 5, class 4 plus class 5, you are adding under addition modulo 9. The 9 can be written as 1 into 6 plus 3. Therefore, you see that it falls in the class 3. So, we find that you add any two elements, the resulting element will fall in the set. Therefore, the closure property is satisfied. Okay. Now, this is one. Then, associative property. That is for all, okay, for all A, B, C belonging to Z6, A plus B plus C must be equal to A plus B plus C. This again, understand that these are all 6, modulo 6, addition modulo 6. Here the operation is, let us take this, see, let plus B, 6B equal to star operation. Let us take this so that we can avoid writing it, it's a command. So you can write even star, here star, this is 6. So wherever this plus 6, so what happens here is that you take any two elements, let us take any two elements, any three elements, See, any three elements. 3 plus 4 plus 5. Add. Check whether this is true, because 3 plus 4, what is here? 3 plus 4? 3 plus 4 is 1. So this LHS 3 star 4 plus 5. 3 plus 4, see, 3 plus 4 is 1. 1 star 5, see, 1 star 5 is 0. Right, RHS, take this. See, 4 plus 5, what is 4 plus 5? 4 plus 5 is 3. See? This 3 plus 3, see? 3 plus 3 is 0. So LHS is equal to RHS. Therefore, associative property satisfied. So associative property is satisfied. Now we have proved that closure property is satisfied, associative property is satisfied. Then see whether the identity element exists. What is an identity element? The existence of identity element. See? Existence of identity. Check. Check for the identity element. See, this is identity element. That is, there exists an A belonging to E. I will call it as E. There exists an E belonging to Z6 such that E plus A is equal to A plus E is equal to A for all A belonging to Z plus 6. So this is the meaning of this. That means you just see that you can find the 0. The 0 is the identity element. 0 plus anything. See, 0 plus any element is itself. Here, see, obviously, from the table, it is clear that 0 belonging to Z6 is the identity. See, 0 plus C, because 0 plus A is equal to A for all A belonging to Z6. This A means any 1, 0, 1, 2, 3, 4, 5, any class, I mean any. So this we have established the identity element. Now, having proved the identity element, last one more property has to be verified. If that property is also satisfied, then this becomes a group. Okay. Now, what is the property? Existence of inverse, additive inverse. Here we call it as the additive inverse with respect to Z plus 6. It is an inverse with respect to plus. See, existence of fourth one is existence of inverse elements. Inverse element with respect to plus 6. With respect to plus 6. With respect to this, there must be. Now you see that is for any A belonging to Z6, there exists a B belonging to Z6 such that A plus B is equal to the identity element. Here A plus B must be equal to your 0 element, because since 0 belonging to Z6 is the identity element. So this is the identity element. This is the 0 is the identity element. So this is 0 is the identity element. Now we just take any element here. Now you can just see that for 1, for 0, 0 is the identity element. For 1, 5 is the element. So you see that 1, see, 1 plus 5 is equal to 0. Under 6. See, 1 plus 5 is equal to 0. Similarly, 5 plus 1 is equal to 0. And 2 plus 4 is equal to 0. And 3 star 3 is equal to 0. That means you see that for 1 the inverse element is 5. For class 1 the inverse element is class 5. And for 2 its inverse is class 4. And class 4 it is class 2. For class 5 it is class 1. For 3 the inverse element is itself. So on addition under modulo 6, you see that it happens to be 0. Therefore, you see that the inverse elements also present. Because of these reasons, you see that because the 4 properties, namely closure property is satisfied, associative property is satisfied, the identity element exists, and also the inverse, identity inverse with respect to modulo 6 is also present for any element in the same set. Therefore, the 4 properties are satisfied. Hence, this Z6 plus 6 is a group. Now, I write it here. So, see, therefore, closure is satisfied. Closure property is satisfied. Number 2, associative property is satisfied. Identity element exists. And addition mode, see, inverse elements is present for any A belonging to Z plus 6 inverse element with respect to plus 6 addition modulo 6 operation, and therefore this Z6 plus 6 is a group. Now incidentally we find that now you see that I have written something here. Incidentally, we find that for any elements A and B belong to Z6, A plus B is equal to A star. Here star is nothing but plus 6. See, here I have written here addition modulo 6 operation. So it belongs to the same set. That is A plus B is equal to B. See, 2 plus 3 is equal to 5 and 3 plus 2 is equal to 5. Very obvious. And you see that 4 plus 3 is equal to 1 and 3 plus 4 is also equal to 1, and 5 plus 4 is equal to 3, and 4 plus 5 is equal to 3, and 4, see you have got here, see 1 plus 4, see 1 plus 4 is 5, 4 plus 1 is 5, and here you see that 5. So you see that for any two elements, if you take A star B is equal to B star A, and therefore commutative property is suffered. Therefore commutative property is satisfied. Therefore Z6 plus 6 is an abelian group. So it is an abelian group. So what I have proved here is that, so in simple words, this is nothing but Z. This table gives you the Z plus, that is these are all classes, and if you add two classes, then add the numbers and write it as a multiple of 6 plus the remainder. The addition of these two classes will fall in the class which is shown as the remainder. The remainder tells you the class in which the sum of the two classes fall. Okay. Now you see that we write like this and we check the closure property. Closure property is satisfied. Associative property I have shown you with examples how they are satisfied. So associative property is satisfied. Identity element your class 0, that is satisfied, and the inverse elements, use the inverse element means now 0 happens to be the identity element. If you take an element if you take an element A, if element B is the additive inverse, if you add these two, it must become 0. So if that is so, then A and B are said to be inverse of each other, additive inverse of each other. Now we will check, see 2 plus 4 is 6. So the inverse of 2 is 2 and 4 inverse of 4 is 2, and we find that for any element there exists inverse. Therefore the inverse also present, identity is present, closure is satisfied, associativity is satisfied. Hence this Z plus this set Z6 under the operation plus 6 is a group. Not only that, you find that the commutative property or commutativity also holds good. That is commutative property, namely class A star class B is equal to class B star class A for any two elements there, and therefore this is not only a group but is also an abelian group. It's called an abelian group. We'll see more problems in the coming days.